Okay, let us discuss list comprehension. And yes, this is a Python construct. I don't know of it appearing in any other language other than Python. So yeah, let's dive in. And what is list comprehension? It is a code condensing operation that allows you to create and populate a list on a single line using a for loop. So it's a data population kind of deal where, so obviously list comprehension involves a list. It's a way to create and add data to a list using a loop, using automation on a single line. So really it condenses, and it takes several lines, it condenses them into a single line. Yeah, code condensing operation. And really it's a way a lot of people use to make one-liners in code, and really it's never really necessary to do list comprehension, but it's a way to shorten lines of code and in many ways make your code look cooler and more uber, if that is a term. And you may wonder, where does the comprehension and list comprehension come from? It's derived from the concept of mathematical set comprehension. I've never seen mathematical set comprehension, but just giving this background, it definitely makes sense why it's called comprehension now. Without this, I really had no idea why it was called comprehension. But there you go, list comprehension defined. And now we're going to get into some code and look at this in operation, as we should. Yep. Pulling up into PyCharm here, and let's first look at list creation and population without list comprehension. So you create your little list, and I've got a list, an empty list, and I want to put some data in it, and I want to do it in kind of in an automated way. Well, I could create a loop like this, and let's say I want to create a list of that consists of a sequence of odd numbers. I could go like 1 to 20 and have a step of 2, which would generate the odd numbers from 1 to 19, and then I could append to the list. And if I check this out by printing, you're going to see that I've got a list here. Yeah, this is all fine and good, and it's taking me 3 lines to do this. List comprehension can condense these 3 lines into one, and I can have my for loop and my appending and my list creation all on a single line. Here's how it looks. You begin with the name of your new list because you're going to create and populate a list on the same line. So you got to have a variable to store your list in. I'm going to call this one odds, and go equals, and then create a set of brackets, of course, for the list. Inside these brackets, I'm going to do my same for loop header notation. And I'm going to generate the same kind of list. So I'm going to copy that stuff, the range information, straight up. Now, I got my for loop in there, and then what you put at the beginning of your list comprehension notation is what you are going to append for every iteration. And what are we going to append for every iteration? We see it right there on line 6. We're going to append I, and so we simply put an I at the beginning here. And you see a difference with list comprehension, where the format is this. You have the header of the for loop at the end, and at the beginning you have simply the data that you will append for each iteration. And notice you don't even use the append function. The appending is implied. Remember that. The appending is implied. So you just put the data that you're appending for each iteration, and it will do the appending in the background. And there's your basic form of list comprehension. Variable name equals brackets, what you're appending, and then the loop header. I'll go ahead and print this, and you'll see that it's got the same stuff in it. Yeah, I condensed those 3 lines down to 1, and there you go. Time for another example. Yeah. But there's your basic list comprehension straight up. And let's think of another example where we start with a list of numbers. And let's say I want to generate another list from this list where I take these values and perform some calculation on each element. Let's say I want to square each element and then place them in a new list. Here's my list comprehension solution for this. First, I'm going to put what I'm appending, which will be the square of each element. And I can create my header, my for loop header. And in my for loop header, I'm going to be looping the length of the list. And for each element in the list, I'm going to raise that element to the power of 2. So I'm going to create a list of squares of these elements. Let's see what it looks like. Curious minds want to know. See the transformation. You have a list of squares, squared 10, 20, 30, 40, and 50. Yeah. So there's performing a calculation on each thing. But yeah, you see the format where what we're appending, then the the for loop header. And so list comprehension works best on loops where all you're doing is you'll have a single line loop body where you're going to be populating a list. For multi-line kind of complex situations inside of a loop where you're also appending to a list, they're just not going to work. You need kind of a simple, many times one line body where you're going to be doing appending. That's the situation you're going to be able to derive list comprehensions from. Yeah. You can add some complication to this though. You can actually add conditionals in your list comprehension where you can conditionally do things. You can conditionally add data or conditionally not. So like if the data fits a certain criteria, you can put it in to the list. You can use if and else in your list comprehension. You cannot use elif. No elif, but if and else are good. And I'm going to show you some examples, or actually an example of if and else. I'm going to pull a list from elsewhere that I'm going to use in a calculation or in a comprehension. So given this list, what if I want to create another list that only includes the evens? I can conditionally include only the evens using an if. Here's what I can do. I'll just loop the length of the list. That's not what I want, the length of all nums. So yeah, where do you put the if and how do you use it? So interestingly, there's different formatting if you're going to use an if versus using an if and an else together. If you're going to use an if only, the if will go at the end of your list comprehension notation. If you're using an if and an else, they will go before the header and after your first appending data. I'm using an if only, so it's going to go at the end. And I'll do this. Modulo 2 equals 0. Yep. So this code is going to include only the evens, and break this down a little bit. So yeah, my conditional says if the element is even, and get this is how it works. It is actually tied to the appending portion, where if the if is true, it will append this beginning portion. If it is not true, this beginning portion will not be appended to the list. Let's check it out in code, or check out the running of this code. And there we see that we're only printing the even numbers because of the conditional. Let's look at the if and else situation. Show you the different formatting. I'm going to just grab the header because the header is the same. Of course, I said the formatting is different for the if and the else. If you have an if and an else, they will actually go in between your appending data and your header. They will go in this in-between portion where you will first have the if, and then you'll have the else. And this is what I'm going to do for the else. All right, breaking this down a little bit. As you can see, a different format. Yeah, we have our if and an else inside or in between. And the if condition is still tied to this beginning appending info, so or data. If the if is true, gonna append this element of all nums. Else is different, of course. So else will say that, or how it's formatted is, the body of the else is to the right of the word else. So we have else odd. What does this do? The else, it also has an appending operation with it. The thing that's going to be appended is to the right of the else. So odd will be appended for situations where the else is true. All nums index I will be appended for situations where the if is true. So for even numbers, it's going to give me a value. For odd numbers, it's going to put the string odd in capital letters in that spot. But this is how if and else are formatted in list comprehension. So yes, you see the difference here? You have the if only is going to go at the end here, And in the second one, if else goes, I guess you can say, in the middle if it's if and else. And again, there is no elif allowed in list comprehension. Let's go ahead and run this. Once I print it out. Print it out. And there we see the situations where we have odd numbers. You see like 55 and 11, blah, blah, blah. We have odd in the output. That is because of the else. So we see that the if and the else are working, of course, and they're observed, and they all work. Good stuff. So we've seen here the basic three formats, or three basic formats of list comprehension. We have the base format with no if and else, the if only, and the if with an else. Of course, there are other forms of list comprehension, and it gets more complex and more configurable from here. For instance, you can nest your list comprehension, or you can nest list comprehensions within list comprehensions, really to create multidimensional list situations. You can also do comprehensions with other data types, like you can do set comprehension and dictionary comprehension in Python. So cool things to look into. But this is a good baseline to start with, the basic forms of list comprehension. Now you can take this on your way, and you've got another thing added to your toolbox. But that's it for me now. I'll see y'all next time. I'm out, and see y'all later.